Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture for 9618 paper number 3 advanced theory A2 content, and today we'll be finishing our chapter number 14. Today we'll be discussing 14.2 circuit switching and packet switching. First of all, let's discuss circuit switching. Circuit switching is a method of switching which is used for establishing a dedicated communication path between the sender and receiver. You have already studied about packet switching in your O-levels, where data is broken into multiple packets and then every packet is sent through a different route. There is no dedicated link between the sender and the receiver. However, in circuit switching, we first of all establish a dedicated link between sender and receiver and then start sending the data packets through that dedicated channel only. This link is always in physical form. PSTN has now mostly converted to digital technology, thus the same method can be used for data transfer that was used instead of voice communication. Previously, circuit switching was exclusively used by PSTN network, the telephone network around the world. However, since everything is digitalized now, so we can use the same concept in digital communication as well. And analog, we have kind of already discussed that the analog telephone network is an example of this. Bandwidth is fixed in this type of switching. That is something you should remember. For data transfer to take place, first of all, the sender would provide the identity of the intended receiver. The system would check whether that receiver is ready to accept data or not, like if you dial somebody's number on your cell phone, the first thing the cell phone tower or the cell phone company does is check whether the other person is free or already on another call. If the receiver is available, a sequence of links is established across the network, so a dedicated pathway is established temporarily between you and the receiver, so you two can talk or communicate with each other. The data is transferred. Once the data finishes, once the call is over or whatever you want to call it, then the links are removed, so the same links can be used for any other dedicated communication. These three are your terminals. It is linked to switch. As you can see, this green highlight shows a dedicated path. You were terminal 1 trying to send a message to terminal 6. A dedicated path is created for you from the network, and as long as the communication is ongoing, as long as the call is ongoing, nobody else can use this path. If meanwhile this terminal 2 has to send a message to terminal 6, it will have to wait. If they have to send a message to anywhere else, they can send, but they cannot use these links or these lines. For now, they are being used for communication between terminal 1 and 6 exclusively. Nobody else can use them unless and until they stop their communication and the links are again available to be used. Advantages: the bandwidth used is fixed. The quality of communication is increased because you're using a dedicated channel. The rate at which data is transferred is also fixed. When switching, no time is wasted in waiting. It is kind of set up instantly. It is preferred when communication is long and continuous. Disadvantages: overall bandwidth requirement is more because you have to fix it. Now, even if you're sending a lower limit of bits, you still have to utilize that much bandwidth. The utilization of resources is not full. You don't completely utilize all the resources. Some of them are always wasted. Since a dedicated channel is created or used, the transmission of other data becomes impossible. Like if you're sending data to terminal 6, nobody else can send data to terminal 6 as long as you are talking to it. The time taken by two stations for the establishment of physical link is too long. It is quick, but for a computer which works in microseconds and milliseconds, it is a little bit long if you're comparing it with packet switching. which is more instantaneous. Circuit switching is expensive because connections have to be created by using dedicated pathways, so the cost is ultimately more. The link between sender and receiver will be maintained until and unless the user terminates the link. So if you don't hang up, if you don't terminate the link can continue for hours and hours. Packet switching, about which you have already studied in your O-levels as well, but this is a little more detailed breakup because obviously you're in A2. This is defined as connectionless network, where you don't need to create dedicated pathways, dedicated connections. You just use whatever way which is open and available and free to send your message to the intended destination. Before transmission, packets are divided into message is divided into data packets, and then those data packets, each of them is theoretically at least sent individually through different routes or whatever is available, and routers play a very vital role in all of this. The actual data in these packets are carried by the payload, whereas we have the header and the trailer for the completion of the packet. When the packet arrive at the destination, it is the responsibility of the destination to put them back into the right order. And here is a reminder of how packet switching works. You break your message into packets, then every packet goes through a different route. It reaches its destination out of sight without an order, so it has first to be placed in an order, and then the original message can be opened. Advantages: no delay in delivery of packets as they are sent to destination as soon as they are available. No requirement for massive storage space as the information is passed to destination as soon as possible. Failure in links does not stop the delivery of packet, or you can say failed routes can easily be rerouted. If a connection is damaged or not available, you can simply move around it. Multiple users can use the same channel while transferring their packets, because it's not dedicated. Anybody can use any wire, any link to transmit their channel. If Terminal 1 is talking to Terminal 6, others don't have to wait to send their messages to Terminal 6. Communication can take place simultaneously. The usage of bandwidth is better because the bandwidths keep the use of the bandwidth consumed by this actually corresponds to the size of the packet or the size of the data, so it can be more or less according to your needs. So theoretically at least no bandwidth is wasted. Disadvantages: installation cost is expensive. Delivery of these packets become easy when complicated protocols are used. So basically what I'm trying to say, if you don't put in a lot of protocols in place, then your setup can be faulty. High quality voice calls cannot use packet switching because there is a lot of delay, because packets always arrive out of sight. Similarly, for live transmissions, it is also not recommended. Connectivity issues may lead to loss of information. Packet hopping may lead to loss of information and delay in the delivery of the information. Here's a little comparison between the two. Circuit switching in circuit switching you need a dedicated circuit or a dedicated link to be established before you can send your message. In packet switching, every packet contains the destination information, so a dynamic route can be created on the go. A uniform path is followed throughout the session in circuit switching, whereas in packet switching there is no fixed or uniform path. In circuit switching, it is ideal for voice communication and almost no delay at all. For packet switching, there is a lot of delays and it's good for data transmission but not for voice calls. In circuit switching, without a connection it cannot exist, whereas in packet switching, connection is not necessary. It can create its own path according to its destination address on the go. As long as the destination device is available on the network layer, no problem at all. Data to be transmitted is processed at the source itself, whereas in packet switching, data is processed and transmitted at the source as well as each switching station or at each router. Wastage of bandwidth in circuit switching, no wastage in packet switching. Circuit switching cannot store and forward transmissions. Packet switching supports store and forward transmission. Now you don't have to remember all of them. I would say just pick any three of the differences that you find most easy and that should be enough. Now the last thing we have in this topic as well as this entire chapter is application in modern landscape, where you would use packet switching, where you would go for circuit switching. Now circuit switching is still used wherever you are having a real-time dedicated services like traditional phone networks. We still have them, fax networks, we still have them. However, even in this domain, hybrid approaches are much preferred, which are usually known as VoIP, voice over IP, which basically combine the goodness of both circuit and parallel switching in order to effectively deliver the message with as minimum delay and as minimum damage to the intended recipient. Packet switching is the dominant paradigm nowadays. Obviously, that's what digital circuits, digital communication is all about. It excels in scenarios where resource optimization and flexibility are your main concern. However, we cannot completely say that circuit switching has been obsolete. It is still used. Function of routers in packet switch networks. Well, as you already know, router is a network device whose main aim is to forward data packets to its intended destinations. Data sent through the internet is always sent in form of packets, and the primary role of a router is to connect multiple computers or multiple devices or multiple networks together and forward packets to their intended destinations. That is what the routers oversee. That's why their name is router, the one who plans the route for each data packet. How do they do that? First of all, we have receipt of data packet. Routers receive data packets from a network and they examine the header in order to see the destination address. Then they take up routing decision by consulting their routing tables. Using the routing table, they decide what should be the most effective way of sending this packet from the current location to the intended destination. Then they forward it to the next router, or if they are very close, to the intended destination. Routing tables are basically tables that contain addresses of all the available connected nodes in the network. So the router knows if they have to send a packet to, let's suppose, terminal number 65, then the router is terminal number 39, so they know how to plan the route till terminal 65. Okay. Role in packet switch networks. Router are particularly important because they can dynamically adjust routes. As soon as any router receives data packets, it can adjust the route the packet will take till its destination. This happens in real time and it is known as dynamic routing. It doesn't happen in the way that whatever route was decided by the first router, it will be followed throughout. No, every router gets to add or subtract, or every router in the way has the ability to change the route of the packet. They have the ability to find alternate routes. This enhanced network reliability. Any faulty lines can be skipped in real time. It ensures communication is continued even when some paths become unavailable, they become too busy, a collision has occurred, or for whatsoever reason, or a physical problem has occurred, a device is offline or out of commission. Any such things can be rerouted easily, dynamically in real time. And that takes us to the conclusion of chapter number 14 as well as 14.2 obviously. So this is everything you need to know according to the syllabus in chapter number 14. If you have any questions, feel free to ask me in the comments below. Let me know whether you like this or not. Give me a thumbs up if you do. Share it with your friends, and I'll see you guys in the next lecture. Till then, take care. Allah Hafiz.